Let's begin with page 1 of the packet that I asked you to print for the fraction unit. And I had asked you when you ordered your base 10 blocks to also order pattern blocks. So I don't know if people have pattern blocks or if you never got them in, right? They look like this. If you don't actually have the physical pattern blocks, that's okay. I sent you to a website. I don't love the website. I find it kind of cumbersome to manipulate them, but it's better than nothing. All right, so what we're going to look at is adding some fractions using the pattern block. So if we look at number 2, all right, so first of all, they tell you up in the direction. So we just saw in the last clip that what we consider to be the whole is critically important because the fraction depends on the whole. So it would make sense that we would determine that that's the whole, right? One hexagon, which would make this a half, right? Which would make our blue piece a third. So why is our blue piece 1/3? Right? Because it takes 3 of them to make the whole, right? So the blue piece is 1/3, and then half of a third is a sixth, right? So it would take 2/6 to make one whole, or in other words, it would take 6 of these pieces, 6 of my greens, to make one whole. Okay, so that's how I know green is my 6th. Okay, so if I began with this exercise here, where I want to do a red plus a blue, which is a half plus a third. Okay, so 1 red plus 1 blue. Okay, and I want to add these together. I can see that it doesn't quite make a whole, right? In other words, I could see it's almost the whole with the 1/6 missing. Okay, but what I do to model this is I show that each red, each 1/2 is equal to 3 greens, right? So I break everything down to, I represent everything in the green pieces, right? So I would have 2 greens plus 3 greens, right? So the 2 greens would be for the 1/3. Actually, I guess it would have made more sense if I'd put the 3 here and the 2 there, but same idea in the end. So I'd have 3/6 plus 2/6 for a total of 5/6. Okay, so try the next one. Let's try adding 1 blue plus 1 green. All right, in other words, that is 1/3 plus 1/6. Right, and I can look right at that and tell that that is equivalent to my half, right? But why is that equivalent to a half, right? That's because 1/3 is equal to 2/6, right? 2 greens plus 1 green is equal to 3 greens. And that also allows me to understand things about equivalent fractions, that 3/6 is the same as 1/2. Okay, so let's do one more together. 1 red, take away blue. Okay, so I need to be able to take away, remove this amount. Or if I thought about the comparison concept, right? I could think of it that way. This is a half, that's a third. What's different? What's different about them is that one little piece, 1/6. But again, I represent everything in greens, right? The red is 3 greens. Take away 2 greens, leaves me with 1 green. Okay, now on the back page, I'll leave the back page mostly for you to do as suggested homework. What I don't want you to do, though, is I don't want you to just get a common denominator and do the problems, okay? I'm not really interested in the answer so much as the process. But in this example, we're changing what the whole is. All right, we're going to let 2 of these, right, be the whole. That allows me then to get, you know, everything's half the size of what it used to be. So that's going to allow me to get a 12th. Okay, because it would take 12 of those green pieces to equal the whole. One thing we have to consider is how to get a third, right? How do we get a third? Remember, a third is formed by whatever takes me 3 pieces to equal 1 whole. Okay, so if I went like this with 2 blues and another 2 blues, yikes, it's hard to hold the camera and manipulate at the same time, so bear with me, right? It would take 3 sets of 2 blues to make 1 whole. Okay, so that's how I know that a third is represented by 2 of these blues. So I'll leave the rest of this for you to do.